Lotus Academy of Diet and Fitness.
Comprehensive food science.
Chapter 6. Food Sensory Evaluation. Food sensory evaluation is a systematic scientific discipline that examines and analyzes the sensory attributes of food products, encompassing appearance, aroma, taste, texture, and overall sensory experience. This process relies on human senses to provide valuable information about consumer preferences, product quality, and potential improvements. The key components of food sensory evaluation include panel selection, test design, sensory attributes, evaluation techniques, data analysis, shelf life evaluation, consumer insights, and quality control. Panel selection. A trained panel of individuals with heightened sensory acuity is selected, undergoing screening and training to ensure consistent and reliable assessments. This familiarity with evaluation techniques and terminology is crucial for effective sensory evaluation. Test design. Sensory tests vary based on research objectives and the specific attributes under evaluation. Discrimination tests identify differences between samples, while descriptive tests involve rating and describing the intensity of various sensory attributes. Sensory attributes. Specific characteristics perceived by the senses, including appearance, aroma, taste, and texture, are evaluated individually or collectively to create a comprehensive sensory profile of a food product. Various techniques, such as triangle tests, paired comparison tests, ranking tests, descriptive analysis, hedonic scales, and consumer preference tests, capture and measure sensory information in controlled or real-world settings. Data analysis. Collected data undergoes statistical analysis using methods like ANOVA and PCA to extract meaningful insights, identifying differences between samples, establishing sensory profiles, and revealing relationships between sensory attributes and consumer preferences. Shelf life evaluation. Crucial in determining the shelf life of food products, sensory evaluation involves assessing changes in attributes over time. This aids in establishing expiration dates and storage conditions to maintain product acceptability. Consumer insights. Sensory evaluation provides valuable insights into consumer preferences, acceptance, and market trends. Techniques like consumer testing, focus groups, and preference mapping gather data to guide product development aligned with consumer expectations. Quality control. Sensory evaluation serves as a vital tool for quality control in the food industry. Sensory panels can detect defects or changes in attributes impacting product quality and consumer acceptance, enabling corrective actions for consistent product quality. Sensory perception and its relevance to food evaluation. Sensory perception is the process by which organisms gather information from the environment through their senses, such as sight, taste, smell, touch, and hearing. In the context of food evaluation, sensory perception plays a critical role in how we experience and evaluate food. Taste. The sense of taste allows us to detect basic flavors, influencing food evaluation by creating a balance of taste for a more appealing experience. Smell. Olfaction significantly influences how we perceive food, contributing to flavor perception and evoking memories and emotions associated with certain foods. Texture. Tactile perception is closely linked to food evaluation, with texture greatly impacting our enjoyment of food. Appearance. Visual perception plays a vital role in food evaluation, influencing expectations and affecting how we perceive taste and quality. Sound. The auditory aspect of food, though less discussed, can impact our perception and enjoyment. Relevance to food evaluation. Flavor perception. Sensory perception allows a multidimensional experience, identifying individual flavors and combinations to determine enjoyment or distaste. Quality assessment. Through sensory evaluation, the quality of food products can be assessed by analyzing taste, texture, aroma, and appearance. Product development. Sensory evaluation is used by manufacturers and chefs to fine-tune products and recipes, creating more appealing and marketable food items. Consumer preferences. Instrumental in understanding consumer preferences, sensory tests provide valuable insights into what consumers like or dislike about specific food products. Gauging freshness and safety. Senses, especially smell and taste, help determine the freshness and safety of food items by detecting off odors or unusual tastes that may indicate spoilage or contamination. Panel selection in food sensory evaluation. Panel selection is a critical phase in food sensory evaluation, shaping the foundation for a reliable assessment. The chosen panel must possess the requisite sensory acuity, training, and expertise to effectively evaluate the food product's sensory attributes. Several key factors guide panel selection. Expertise. Seek panelists with specific expertise in the area under evaluation. For instance, if assessing coffee aroma, experienced coffee evaluators would be advantageous. Sensory acuity. Panelists should exhibit well-honed sensory acuity, discerning nuances in sensory attributes. Preliminary tests can gauge their ability to detect and recognize sensory stimuli. Diversity. A diverse panel, reflecting the target consumer group in terms of age, gender, cultural background, and dietary preferences, ensures a comprehensive evaluation perspective. Training. Provide comprehensive training, encompassing sensory skills enhancement, evaluation techniques, terminology, and standards. Workshops, reference sample sessions, and calibration exercises contribute to aligning evaluations. Panel size. Optimal panel size, typically 8 to 12 individuals, depends on evaluation complexity and available resources. This size facilitates effective discussion and consensus during evaluations. Screening. Implement a screening process to identify individuals motivated to participate. Questionnaires, interviews, or preliminary tests assess sensory abilities and commitment to the evaluation process. Rotation and monitoring. Periodically rotate panelists to prevent sensory fatigue, ensuring ongoing training and monitoring to maintain consistency and reliability in evaluations. Ethical considerations. Uphold ethical standards, ensuring panelists' privacy, providing compensation for their time, and obtaining informed consent for participation. Test design in food sensory evaluation. Test design plays a pivotal role in gathering meaningful and reliable data on the sensory attributes of food products. A well-designed test is essential for obtaining accurate results. Key considerations in test design include: objective. Clearly define the evaluation's objective, specifying the information to be gathered, such as product acceptance, formulation comparisons, or the impact of processing methods on sensory attributes. Test type. Choose an appropriate test type based on the objective, such as discrimination tests, descriptive tests, consumer preference tests, or effective tests. Experimental design. Select an appropriate experimental design to control variability. Options include completely randomized design, balanced and complete block design, and Latin square design. Sample selection. Choose samples representing variations in the attributes under investigation, randomizing their presentation order to minimize order effects. Panelist instructions. Develop clear instructions for panelists regarding the evaluation procedure, attributes to be evaluated, and any specific criteria or scales. Replication. Plan for sufficient replication to enhance result reliability, involving the evaluation of multiple samples of the same product or condition. Presentation order. Decide on the order of sample presentation to minimize biases or order effects, whether sequential, randomized, or counterbalanced. Statistical analysis. Determine appropriate statistical techniques for data analysis, such as ANOVA, regression analysis, or multivariate analysis, based on test type and research objectives. Validation. Validate test design and procedures through pilot studies or pre-testing with a small group of panelists to identify issues, refine protocols, and ensure test reliability. Ethical considerations. Adhere to ethical standards, obtaining informed consent, ensuring privacy and confidentiality, and complying with relevant regulations. Sensory attributes in food sensory evaluation. Sensory attributes are crucial in understanding the qualities perceived by the senses in a food product. Commonly evaluated sensory attributes include: taste. Basic flavors perceived by taste buds, including sweet, sour, salty, bitter, and umami. Aroma. Perception of volatile compounds influencing flavor perception and overall eating experience. Texture. Physical properties such as hardness, chewiness, and viscosity, assessed for tactile and mechanical perceptions. Appearance. Visual characteristics like color, shape, and glossiness influencing taste and quality perception. Mouthfeel. Sensations experienced during consumption, like creaminess or astringency, related to tactile and thermal perceptions. Flavor. Combined perception of taste, aroma, and mouthfeel, shaping the overall sensory experience. Aftertaste. Lingering taste post-consumption, including descriptors like bitterness or sweetness. Off flavors or off odors. Undesirable flavors or odors indicating potential quality issues. Spiciness or heat. Sensory attribute associated with pungent compounds, often evaluated in spicy foods. Overall liking. Subjective evaluation of a food product's overall acceptability, reflecting panelist, impressions, and preferences for combined sensory attributes. Food sensory evaluation employs diverse techniques to assess and measure the sensory attributes of food products, collecting both objective and subjective data from trained panelists or consumers. The following are commonly used evaluation techniques. Discrimination testing. Triangle test. Panelists identify the odd one out among 3 samples, 2 of which are identical. Duo-trio test. Panelists distinguish between a reference sample and a test sample. Descriptive analysis. Flavor profile analysis. Panelists evaluate the intensity of different flavor attributes using a structured flavor profile sheet. Quantitative descriptive analysis. Panelists rate the intensity of predetermined descriptors for various sensory attributes. Hedonic scaling. 9-point hedonic scale. Panelists rate products on a scale from 1, dislike extremely, to 9, like extremely. 5-point facial hedonic scale. Panelists express their liking using facial expressions. Ranking. Panelists rank multiple samples based on specific attributes or overall preference. Consumer testing. Sensory data is gathered from the target consumer group through questionnaires or interviews. Time intensity testing measures how the intensity of specific sensory attributes changes over time. Just about right scale. Panelists assess the optimal intensity of a specific sensory attribute on a scale from too low to a just about right to too high. Check all that apply. Panelists select multiple descriptors from a list to identify relevant sensory attributes. Data analysis. Data analysis in food sensory evaluation involves processing and interpreting collected sensory data to derive insights about sensory attributes, product quality, and consumer preferences. Various techniques are employed for comprehensive analysis. Descriptive analysis. Descriptive analysis aims to summarize and compare sensory attributes. Mean intensity analysis calculates mean scores for attributes compared using ANOVA. Principal component analysis identifies patterns, and cluster analysis groups samples based on similarity. Discrimination testing. This analysis assesses differences between samples through techniques like proportion calculation and statistical tests, example, binomial or chi-square tests, to determine the significance of observed differences. Preference mapping. Preference mapping explores consumer preferences and sensory attribute relationships. Methods include analyzing preference data with PCA, correspondence analysis, or algorithms like partial least squares and conjoined analysis. External preference mapping considers external variables using multivariate techniques. Consumer testing. Consumer testing data analysis focuses on preferences, acceptance, and behavior. Overall liking analysis compares mean scores or proportions using statistical tests. Preference drivers are identified through techniques like PLSR or multiple regression analysis. Segmentation analysis categorizes consumers based on preferences or behavior using clustering or latent class analysis. Time intensity analysis. Time intensity analysis examines the temporal aspects of sensory attributes. Area under the curve quantifies attribute intensity or duration over time, allowing for comparisons between samples. Statistical analysis. Statistical techniques play a crucial role in sensory data analysis, testing for differences, correlations, and relationships. Common methods include ANOVA to identify differences between samples or groups, correlation analysis to identify relationships between sensory attributes or external variables, and multivariate analysis, example, PCA, PLS, cluster analysis, for exploring complex relationships in the data. Repeated measures ANOVA is utilized to analyze changes in attribute intensity over time. Shelf life evaluation. Shelf life evaluation in food sensory analysis is a critical process that involves systematically assessing changes in sensory attributes to gauge a food product's quality and freshness over time. This evaluation is pivotal for food manufacturers, retailers, and consumers as it provides insights into how long a product can maintain its desired sensory characteristics and remain suitable for consumption. Key aspects and methods. Selection of sensory attributes. Identify the crucial sensory attributes defining the quality of the food product throughout its shelf life, considering factors like taste, aroma, texture, appearance, and overall acceptability. Sampling plan. Develop a sampling plan ensuring representative samples are collected at regular intervals based on factors such as product type, expected shelf life, storage conditions, and the rate of sensory changes. Storage conditions. Store samples under conditions mimicking expected storage conditions, including temperature, humidity, light exposure, and packaging, adhering to recommended guidelines for accurate assessment. Sensory evaluation. Conduct periodic sensory evaluations by trained panelists using descriptive analysis, consumer testing, or other methods, depending on the evaluation objectives. Sensory analysis methods. Apply appropriate sensory analysis techniques, like scoring attribute intensity, hedonic scaling, preference mapping, ensuring consistency in evaluation protocols and panel training for reliable results. Statistical analysis. Analyze collected sensory data over time using statistical techniques, example, regression analysis, survival analysis, or accelerated shelf life testing to determine the rate of sensory deterioration, critical time points, and estimate remaining shelf life. Microbiological and chemical analysis. Complement sensory evaluation with microbiological and chemical analyses to monitor microbial growth, nutrient composition, oxidation levels, and other parameters, providing a comprehensive understanding of product quality and safety. Shelf life determination. Based on sensory and analytical data, establish the point where sensory attributes become unacceptable or significant changes occur, indicating the end of the product's shelf life. This involves setting quality specifications or sensory cutoff points. Packaging evaluation. Assess the impact of packaging materials, formats, or technologies on the food product's shelf life. Recognize the crucial role of packaging in preserving sensory quality by protecting against moisture, light, oxygen, and microbial contamination. Consumer insights. Consumer insights in food sensory evaluation involve understanding consumer preferences, perceptions, behaviors, and needs related to food products through sensory evaluation methods. This process informs product development, marketing strategies, and overall decision-making in the food industry. Key aspects and methods include consumer testing. Consumer testing directly involves consumers in the sensory evaluation process. They assess food products based on sensory attributes, overall liking, and other factors, providing insights into preferences, acceptability, and purchase intentions. Preference mapping. Preference mapping techniques, such as preference mapping algorithms, partial least squares, PLS, or conjoint analysis, identify patterns and relationships between sensory attributes and consumer preferences. These methods optimize product formulations by pinpointing attributes that drive liking. Product optimization. Insights from sensory evaluation guide product optimization efforts. By adjusting or optimizing sensory attributes based on consumer preferences, companies can enhance product acceptance. Market segmentation. Sensory evaluation data contributes to market segmentation by identifying distinct consumer groups with unique preferences. Understanding these preferences allows for targeted marketing strategies and tailored product development. New product development. Consumer insights from sensory evaluation are crucial in developing new food products. Incorporating preferences and sensory attributes into the development process aligns products with consumer desires, increasing market success. Branding and marketing. Sensory evaluation informs branding and marketing strategies by understanding attributes that resonate with consumers. This knowledge allows companies to communicate unique selling points and differentiate products from competitors. Packaging design. Sensory evaluation assesses the impact of packaging on consumer perceptions. Considering factors like aesthetics, ease of use, and sensory attributes associated with packaging materials helps create packaging that enhances consumer experiences. Quality control. Consumer insights from sensory evaluation establish sensory specifications and quality control measures. Aligning sensory attributes with consumer expectations ensures consistent product quality and allows companies to monitor deviations impacting satisfaction. Sensory marketing. Sensory evaluation data informs sensory marketing strategies, creating multisensory experiences to engage consumers. Understanding how sensory attributes influence perceptions helps design campaigns leveraging specific cues for brand recognition and emotional connections. Quality control. Quality control in food sensory evaluation encompasses systematic measures and processes to guarantee the reliability, accuracy, and consistency of assessing food product quality through sensory evaluations. The key aspects of quality control in this context include standardized evaluation protocols. Implementing standardized protocols and procedures is crucial. These should offer clear guidance to panelists on sample presentation, evaluation techniques, data recording, and any specific criteria or scales. Standardization ensures consistency across evaluations, minimizing variability. Calibration and training. Regular calibration and training sessions for sensory panelists are essential to maintain their acuity and alignment of evaluations. Calibration involves providing reference samples to ensure agreement on sensory attributes and intensity. Training programs help refine sensory skills, familiarize panelists with evaluation methods, and ensure shared understanding of objectives. Panel performance monitoring. Continuously monitor panel performance to identify issues impacting the reliability of sensory evaluations. This includes periodic performance checks, statistical analysis of panelist scores, and tracking inter-panelist agreement. Addressing performance issues through feedback, retraining, or rotation helps maintain evaluation quality. Statistical analysis. Apply appropriate statistical techniques to identify outliers, detect significant differences, and determine variability within evaluations. Methods like analysis of variance quantify differences between samples, assess attribute significance, and provide insights into product quality. Replication and randomization. Reduce variability and enhance reliability by incorporating replication and randomization techniques. Replication involves evaluating multiple samples to estimate precision. Randomization minimizes biases and order effects in sample presentation. Reference samples. Include reference samples or standards to provide a consistent benchmark for panelists. These samples aid in training, calibration, and assessing evaluation consistency across sessions or panels. Documentation and record keeping. Maintain comprehensive documentation covering sample details, panelist information, evaluation protocols, results, and encountered issues. This documentation serves as a reference for future evaluations, quality control audits, and continuous improvement efforts. Audits and quality assurance. Conduct periodic audits to ensure compliance with established protocols. Internal audits, external assessments, and participation in proficiency testing programs help benchmark performance against industry standards. Continuous improvement. Foster a culture of continuous improvement by regularly reviewing and updating quality control processes and procedures. This ensures that the methods employed stay current and effective in maintaining high standards in food sensory evaluation. Thanks for tuning in. Don't miss out on captivating content about diet and fitness. Subscribe now